Any questions? Yes. Yeah, we can have like one pager, and that only includes formula. I mean, basically you can write anything you want, but it's only one page. Okay. And don't write, like the answers for the multiple choice question, like, like A, C, B, C, and A. Don't write it. Just write the stuff that you need to get your mind working. But here are the few last announcements. So this is our last class. So thank you and congratulations to you all for making it this far. So the time of the final exam is finalized, and it's going to be next Monday from 7:40 to 9:40 p.m. We will have the exam in this classroom. The format of the exam is that you will have multiple choice questions, 50 questions, and 2 applied questions. So the total points is 180. So you have 150 for the multiple choice questions, which means 3 points per question. And each applied question will be worth 15 points. Okay? So that's it. That's the final exam. You will have 2 assignments left, homework and quiz for chapter 10, and the reflection report. And I said for the reflection report, you just write your thinking, like what is your reflection on the course. It doesn't matter. It just, like you can say what you like about the course, what you hate about the course, what would be better in terms of like how the materials were delivered, or basically you can write anything that you like or don't like, or you're thinking about the course. And also, it's no more than 2 pages. Okay, it's the end of the semester. I don't really have time to read the whole thing. Like multiple pages of for each student. And the last thing is the practical exam. So it will stay open until right before the exam, perhaps, the actual exam, perhaps. But don't wait until the last minute to do the practical exam. And then Reid will tell you, Reid will probably lead the part of the practical exam today. And he will probably tell you that this is way harder than the previous 2. Okay? So you need to do that. At least go over the questions 2 times before even thinking about like doing just fine for the final exam. So that's not a warning. I'm sorry, that's a warning, but Oh, so the final exam only cover chapters 8 to 10. So you can forget about chapter 7 before, the one before. So only chapters 8 to 10. The applied question is mostly about chapter 10, regression, correlation, coefficient. So that's all for the announcements. For the any questions? We have one question from the homework is due on Sunday, perhaps? Is it Saturday or Sunday? So today it is 27th. Anyway, it's due the 30th of April. So it's I don't know for the Saturday or Sunday, but it is what it is. Any questions? Are we good? All right. So let's do one more time that question, because I also received a couple of questions from students regarding, the confusion around the applied question. And we're gonna clarify a little bit on that. Okay, let's go with this one first. So the first question asks you, now for the applied questions, the theme is like you will have 3 pieces of information. So the whole purpose is to use regression and correlation coefficient in applied works, okay, research, applied research. So you will be given 3 pieces of information. You have the first one. So basically, we will ask you to analyze the relationship between 2 variables that are, often used in research, whether it's economics or it's in healthcare or it's in, social policy, something like that. So here we have 2 variables that are correlated over time because it's, unemployment rate. This is unemployment rate measured at 2 different points of time. So the first piece of information is a scatter plot where you will have a figure that shows all the data points that belong to the sample. Okay, so you have unemployment rate. So imagine that you have 2 columns in the data set. The first one is unemployment rate in 1995, and the second column is unemployment rate in 2000. Each data point represents a state. Okay, so we have here 30 states. That's the first piece of information. The second piece of information is a snapshot of the sample. So exactly like I just wrote down here. So you have a list of states, the unemployment rate in 1995 for each state, and the unemployment rate in 2000 also for the same states. The last piece of information is a regression output that you have when you run a regression where the dependent variable is unemployment rate in 2000, and you link that with unemployment rate in 1995. So the theory behind it is that because unemployment rate at 2 different points of time are correlated, by construction, right? Because it's the variable that is measured at 2 different points of time. So you would expect that the unemployment rate, in terms of, the theoretical prediction, you would expect that in unemployment rate in 1995 is going to have some sort of predictive power for the unemployment rate in 2000. Okay, so we are establishing a link between unemployment rate in the past and unemployment rate in the future. Okay, so that is also kind of like this same kind of a thing that you have regardless of the questions, like the content of the question, you have two variables that are correlated by nature, or two variables that are from, two pair of samples, and then you be asked to analyze relationship between these two variables. So the first question is usually asking you to state your hypothesis or your expectation based on your understanding, based on your theory, how the two variables are related to each other. Okay, so sort of like, what is your expectation in terms of the relationship between unemployment rate in the past and unemployment rate in the future? Okay, so that's sort of like the first question. And based on your prediction, you're supposed to write down the population equation that links the two variables. So in order to write this population equation, we need the first assumption, which is that if you believe that there is a relationship between the two variables and the nature of the relationship is linear, okay, then you will have an equation that is linear right? So this is the equation that links the two variables. Agreed? And it has to be a linear equation. That's the first thing. The second thing that you're supposed to do is to argue that because it belongs, so it reflects a relationship of population, you have to have an additional term here, which is called noise or error terms or unforeseeable factors, whatever it is. But that are things that you cannot observe, but potentially affect the unemployment rate in the future. Okay, so you need to add here an error term, and then you might, reason what do you mean by the error term? Let's say that if the dependent variable here is unemployment in 2000, then what would be, according to you, what would be the factors that we cannot observe but potentially affect unemployment in 2000? Notice that in the sample, you only observe unemployment in 1995. So what are the potential factors that might affect unemployment in 2000? Or unemployment at the moment? Exactly. So I say that the term here is inflation, CPI in 2000. And this one is included in the error term, and you cannot observe, at least from your sample. Okay? So that's why you need to add this term to the population equation, because it represents the factors or the things that you cannot observe but affect the dependent variable. So that's the second question. Now the third question is basically asking you what the regression equation is. So the regression equation is coming from running a regression using a sample, okay, that we have. So if you want to write down the regression equation, you would have the predicted value of unemployment is equal to beta 1 hat YR 1995 plus beta 0 hat. Okay. So it's the same thing here. You're assuming that the relationship between these two variables of a population takes this form, but from the sample, your estimate suggests that the relationship between these two variables is determined by these two estimates. This is, what is it called? This is a slope estimate, and this is an intercept. Okay, so this is the regression equation that is coming from the sample. Are we good? So that's the third question. Why don't we have the error term in the regression equation? Five points. So here, beta 1 hat is an estimate of beta 1 in the population equation. Beta 0 hat is an estimate of beta 0 in the regression, in the population equation. The error terms has to be included in the population equation, but y is not in the regression equation. Five points. Okay. So question 4, based on an estimate in the regression output, so table 2 is the regression output. Okay. So from this one, from the regression output over there, beta 1 is equal to 0.53, beta 0 hat is equal to 1.07. So the regression equation becomes y hat unemployment, predicted unemployment in 2000 is equal to 0.53 times unemployment in 1995 plus 1.707. This is a regression equation. Question 4. The question is, based on the estimates in table 2, is the correlation coefficient statistically different from 0? Write down the mean and alternative hypothesis, use the t-statistic and p-value and 0.05 significance level to draw a conclusion. How do you formulate the mean and the alternative hypothesis? What is the mean hypothesis? Grant? is equal to 0? No. So it asks you the correlation coefficient. Yeah, it's control or P, whatever. This is the population correlation coefficient, okay? The alternative hypothesis is rho is different from 0. There, you're supposed to formulate these two hypotheses like this. Now, in order to draw a conclusion of whether the population correlation coefficient is different from 0, you can use the regression output. So the estimate that you use is the t-statistic of the slope or the p-value of the slope. Okay? So if you have here the t-statistic of the slope is 6.6 and the p-value is equal to 0. If you compare, so this more simple way to do this is to compare p-value with the significance level. If p-value is less than the significance level, then we reject the null hypothesis. Yes. So we reject the null hypothesis and we conclude that there is sufficient evidence to warrant the decision that the population correlation coefficient is different from 0. Another question that is worth 5 points. Why can we use the t-statistic of the slope here to test whether the correlation coefficient is different from 0? Remember that the correlation coefficient is R, right? The sample is R, the population is rho. So this one is different from the slope estimate. So you can see from here, it's also already given in the beginning. So the correlation coefficient R here is 0.78. The slope is 0.53. So the question is, why are we able to use the t-statistic from the slope estimate to make a decision about the test that involves the correlation coefficient? Another 5 points. But the way that you are supposed to answer this question is that first you form the null and alternative hypothesis, and then you use the t-statistic or the p-value of the slope estimate to draw a conclusion of whether you're able to reject the null hypothesis. Right? The next one is, what would be the increase in unemployment rate in 2020? Sorry, in 2000. That's the typo. In 2000, if unemployment rate in 1995 increases by 2 percentage points, this goes back to the concept of marginal change. Marginal change of unemployment rate in 2000 over the marginal, over the change in unemployment rate in 1995 is equal to what? this is the change. The numerator is change in unemployment in 2000, given 1 unit change in unemployment rate in 1995. What is it equal to? From this regression equation. Exactly. So this is equal to the slope estimate. Okay. So the slope estimate is 0.53. So the question asks if unemployment rate, so this one, instead of going up 1 percentage point or 1 unit increase, it goes up by 2 percentage point, which means 2 unit increase, because the unit analysis here is in percentage term, right? So unemployment rate in percentage term. So if it goes up by 2, then how much the unemployment rate in 2000 will increase? Just multiply this thing with the slope. So this will be times 2, which is equal to 1.06. So the conclusion is that if unemployment rate in 1985 increases by 2 percentage points, then unemployment rate in 2000 will increase by 1.06 percentage point. Okay? Remember that the slope reflects the marginal change of y conditional on 1 unit change of x. The next question, so this question is about prediction. Now suppose that a state has unemployment rate of 7.5% in 1995. So you have the value of unemployment rate in 1995, that is 7.5%. Then what would be the predicted unemployment rate of that state in 2000? Okay, so essentially it's about predicting the value of unemployment rate in 2000. If unemployment rate in 1995 is 7.5%, so you just plug in 7.5 into this as a value of unemployment rate in 1995, and you use these two estimates of slope and intercept, and then you will have the predicted value of unemployment rate for that state in 2000. Make sense? Yes?
7.5 or like 0.075?
7.5. You should know. You should notice.
Oh, right.
The unit analysis here is in percentage. If the state has unemployment rate, so what is the result here? What's the number here? If this one is 7.5, what is the predicted value of unemployment rate in 2000? Just plug 7.5 into this. So 5.04%. Now, if unemployment rate in 1985 is 4%, then what would be the rate in 2000? So this is 40 times, so this would be 2.1, 2.12, 2.12, so it's 3 point, no, it's
We both got 22.3.
22.3%. So which one makes more sense than the other? If you look at this graph, this scatter plot, which one makes more sense?
5.04, right?
Exactly. So you only make predictions if your X values is within the bound that the data gives you. So the bound of X here is from 2 to 9%. If you want to make a prediction where the value of unemployment rate exceeds the maximum value that is given by the data, then the prediction is no longer reliable, okay? It might be true, but it's not coming from the data, all right? Because the value of unemployment rate in 1985, the range of value of unemployment rate from 1995 is from 2 to 9. So the implication here is that you should be careful when you make predictions. If you want to make a prediction where the value of the dependent variables is an outlier compared to your sample data, then the resulting predicted value might not be reliable. And is that it? Yeah. So that's how it's done for questions like this. Any questions? Clarification? No? We good? Anna, do you have any question? Great. I'm not sure how to take when you shaking your head whether it's I don't have any questions or I don't understand at all, or like I don't really know how to take it at this point. But I assume the good thing that you totally got us. Okay, so does anyone have a solution for the two questions that are each worth 5 points? Yes.
It's probably wrong. The first one is the reason there's no error in the question. There are variables worth in the data.
Yes, that is partially correct. But any comments on that or any clarification, or you have a better explanation? I agree with that. So the thing is that when you have, so let's go with X and Y. This is the regression, the population equation. This one is the regression equation. Remember that the method that we used to estimate beta 1 hat and beta 0 hat was based on the assumption that the sum of the square of the difference between y hat and y is minimized or is equal to 0. Okay, so remember the picture that you have like a regression line where you draw the vertical distance between each data point and a regression line, and then you take a sum of squares of those distances and you minimize that sum of square. That would give you the estimates of beta 1 and beta 0. So in mathematical form, essentially what it means is that you minimize, this is the vertical distance between each data point and the regression line, okay? And you square it up. So the solution to beta 1 and beta 0 must satisfy the condition where you have the sum of square, okay, is equal to 0. So it's minimized because it is squared, so 0 is the minimum, right? So that is the condition that the explanation of these two estimates must satisfy, and that you solve this problem. So it's a minimization problem. Solve this. So this one is essentially y minus. So you replace what is y. So it's beta 1 times x plus beta 0 plus not this. Anyway, we don't have time to go over this, but essentially, when you minimize this term, then what you would have is that if you were to add this residual here, okay, the condition of this residual is that the sigma residual square is equal to 0. So essentially with this one. And that's why they often ignore this, the regression equation. Because if you were to add this, then you would have this condition that is met. That is, the sum of the residual squared is equal to 0. And that's why they just ignore this. Okay, good, 2.5 points. How about the second question? Does anyone have an answer for that? What was the second question again? Okay, let's leave it here. The correlation coefficient is different from the slope, but we can use the p-value of the slope or the t-statistic of slope to test whether the correlation coefficient of population is equal to 0. All right, let's go to the next applied question. Uh-oh. So the next applied question, this is based on the research that I published a few months ago. So can somebody read this out loud? Yeah. Yeah. No, I think it's. All right, please stop. Thank you. So here we have, again, two variables of interest. What are the two variables of interest? What are the two variables that we want to investigate relationship between?
Number of COVID cases and percent eligible.
Exactly. So which one is the independent variable and which one is the dependent variable? The independent variable.
Oh wait, no, that's dependent on the vaccination rates, right?
Exactly. So it's the vaccination rate. And let's call it X. And the dependent variable is what? This is vaccination eligibility rate. It's not actual vaccination take-up, but it's just like eligibility for vaccination. The number of new COVID-19 cases. Okay. So again, you have three pieces of information here. The first one is a scatter plot where you have vaccine eligibility rate on the x-axis and number of new COVID-19 cases on the y-axis. And each point here represents the data for each county in Indiana, okay? The second piece of information is a snapshot of our sample where you have the county FIPS, FIPS, in the first column. So these counties belong to Indiana. And we have like 79 counties in total in Indiana. I'm not sure whether it covers the whole population of counties. And the second column is the number of new COVID-19 cases. The last column is percentage of eligible population. That's the second type of information. The last one is a regression output where you regress the dependent variable on the independent variable, which means that you regress the number of new COVID-19 cases on vaccine eligibility rate, okay? And this data is for Indiana as of March 2021. Again, the first question in theory, what is your expectation of the relationship between the percentage of population eligible for vaccines and the number of COVID-19 cases in March 2021? Is it a positive or negative relationship? What is your expectation? Positive? Okay. So it's a negative relationship. Why? Exactly. If a county has a lower vaccination rate, then you would expect that that county would have higher number of new COVID-19 cases, right? Because less portion of the population is covered by the vaccine. So we should expect a negative relationship. What is the population equation? If you want to establish an equation that links these two variables, then what does the equation look like? So let's call this dependent variable as y. So y is equal to what? Beta 1 times x plus beta 0 times the error term or the noise. What does this error term potentially include? Super what? Super spreader event, exactly. Yep, that's one of the factors. So this is the equation, population. The next question, based on the regression estimates provided in table 2, write down the linear equation that links these two variables. Now, if we use our sample and a regression, then the regression equation is what is the value of beta 1? Yes, negative 23.3515 plus 870 point, okay, it is a 70. Oh. So this is a slope and this is estimate. So the slope is negative, which means that the relationship is negative, yes. Base, question 3, formulate the null and alternative hypothesis of the test of whether the correlation coefficient is statistically significant from 0. Use t statistics and p-value and the significance level 0.05 to draw a conclusion whether we reject the null hypothesis. So again, what are the null hypotheses? What are the null and the alternative hypothesis? H naught is correlation coefficient is equal to 0. Alternative hypothesis is different from 0. You're supposed to write the population correlation coefficient. Okay, don't use the sample correlation coefficient. This is not R. This is population correlation coefficient. And you can be based on these estimates the t statistic of the slope and p-value of the slope. So t statistic is 5, sorry, -5, and p-value is 0. So compare that to the significance level 0.05. You have whether, so we reject the null hypothesis. Yeah, exactly. So we reject the null hypothesis. And if you look at the confidence interval for the slope, both the lower limits and the upper limits are negative, which means that what? Which means that the slope is different from 0, right? Because it only, the confidence interval only covers the negative values. Now, based on the linear regression equation, based on this one can make prediction on number of COVID-19 cases given certain eligibility rate. If it currently has the eligibility rate of 20%, sorry, 30%. So if X here is equal to 30, then what would be the predicted number of new COVID-19 cases? So just multiply that, the slope, with 30, and then add the whole thing by intercept. What's the value of, what's the predicted value of number of COVID-19 cases? What? No, this is minus. The slope is negative.
I got 169.5.
169.5. All right, that sounds about right. Now, so that's the answer for the first part. So this is the number, the predicted number of new COVID-19 cases if the eligibility rate is 30%. Now the next one, what if the county has had the rate of 1% and 60%? So if this one is equal to 1 instead of 30, what's the value of number of new COVID-19 cases? How many? Sorry. 846.65. What if this one is 60? Yeah, it's asked for 60 over there. Yeah. Negative 531.60. All right. So if you compare these two predicted values, which one is making more sense? Can it be negative? No, right? So this one is rubbish. How about this one?
That makes sense, right? Because that's a low vaccination rate, or low eligible rate.
Exactly. So 1% is still greater than 0. And this one is entirely possible. But let's check the scatter plot here. So scatter plot, the range of eligibility rate is from 26% to around 37%. So the value of x that is equal to 1 is beyond that bound, right? So even though that is positive and it's entirely possible, but because the value of x doesn't belong to our data, then what we will say is that we will be very careful to make prediction if the eligibility rate of a county in Indiana as of March 2021 is equal to 1%. Okay? So remember that two things that you need to check. The first thing is that if the number here that has to be positive, but it turns out that the predicted value is negative, then you need to be cautious. The second thing is that if the value independent variable is not belonging to our data, which means that this is not county in Indiana, okay, then you so need to be very careful. Next question, what does intercept, what does it mean?
Value is 0.
Exactly. So it's the number of COVID-19 cases if x is equal to 0. Oh, it's not coming from our data, right? So no countries in our data has eligibility rate of 0, but in terms of mathematical meaning, it means that the intercept is the value of y when x is equal to 0. The next one is what would be the next question, what would be the percentage of eligible population to achieve 0 new COVID-19 cases? So in order to have y that is equal to 0, then what would be the value of x?
0 for y, right?
Exactly. So plug in this 0 and solve this. Unify x. So what is the value of x?
I got 37.25.
37.25. Does it look realistic?
Oh, no.
Why?
Because you need like 99% for everything. And even then you wouldn't get rid of all COVID cases.
Again, you need to look at.
Well, yeah, it's not my data. I thought you were asking like why does not make sense in the real world.
No, remember this is number of new COVID-19 cases in March of 2021. So it's entirely possible that you have a county in Indiana that had no new COVID-19 cases.
Yeah.
Right?
Yeah.
Yep. So that's it. The last one, okay. Can you say anything about the causal effect of eligibility rate on number of new COVID-19 cases? So suppose that this is an estimate. Can you say anything about whether this estimate is a causal effect of eligibility rate on number of new COVID-19 cases and why or why not? Yeah, but that's true. But like, what are the potential factors that might invalidate the causal interpretation of the estimate?
Would it be like just people not going out as much? Would it be similar to basically like the error for earlier? Yeah. Like just two key factors, like people not going out because of so many cases.
Okay. Okay. Good. But does anybody else have a different answer? Emily? So if they already had COVID, then what?
It's less likely for them to get COVID again.
Oh, okay. So this is still in this noise, right? Okay. Anybody else? When is it that correlation doesn't mean causation? What is the situation when you have exactly? So what is the potential variable that causes both to change? So Graham's points that there are many other unforeseeable or unobservable factors that might affect number of new COVID-19 cases, right? So all the factors that in the error term here that we cannot observe but affect this, but it just means that you don't the predictive power of these two estimates, the slope and the intercept, the predictive power is not very strong in terms of, predicting the number of new COVID-19 cases because you ignore all the other factors. But it doesn't necessarily mean that the estimate here is not a causal estimate. You need to find a variable or a factor that affects both the eligibility rate and the number of new COVID-19 cases. If there is such factor, then this is what is called, I think it's spurious correlation. So the answer to this question is you need to find a variable that affects both number of new COVID-19 cases and the eligibility rate. So what is a potential variable? Okay, just one thing to think about. We only have like 10 minutes left. You want to do the practice exam or you want to go with the bonus question? That question. Remember that the practice exam, so for people online as well, if you want to do well in the final exam, probably you should spend some time for the practice exam. Probably you should spend you should do at least 2 attempts for the practice exam because that exam, the final exam is pretty horrible. It's extremely hard, and the thing is, it's way harder than the previous two. So you better spend some time on the practice exam. The difference between the final exam and the previous two is that for the previous two exams, you have, in the practice exam, you had, so the number of questions in the practice exam is less than, or at least was less than or at least equal to the number of questions in the actual exam. But for this final exam, the number of questions in the practice exam is larger than the number of questions in the final exam. So essentially, the practice exam covers the actual exam. So if you have done all the questions in the practice exam, then there's a good chance that you can do well in the final exam. But that is conditional on, you doing the practice exam. You don't do the practice exam, there is no way, absolutely no way for you to score better than 80%. You can take that to the bank, because I think that, so for the previous class, so previous semester, the average score for the final exam was 80%. No, it was even less than that. But it did include 2 applied questions. So, what do you want to do next? Any questions? There's still the question over there that is worth 5 points. You got it?
No. I just have a question. What was is it realistic for number 6 for the second applied question?
Yeah, so does it look realistic? So in order to achieve 0 number of new COVID-19 cases, the eligibility rate must be 37.25. So does it look realistic?
Not looking at the scatter plot.
So this one, yeah, then you can conclude that this is that kind of observation is not observed in our data. Or you can like, so here is the 0 new cases, and you can just like find the data point that has the y value of 0. Okay, so if there is a county that has no new COVID cases, then it's entirely possible. Make sense? Yeah, so you can be based on your reasoning. Like, does it make sense to have a country that has new cases? Or you can be based on this scatter plot. It is really beyond, like, if you found like 40 for a value of x here, then that wouldn't make any sense, right? So last chance to have 5 points. I'm essentially giving you for free here, but there's no one is brave enough to even think about this. So why are we able to do this? So let's use this example. The Pearson linear correlation coefficient is -0.494 here. Okay, this is a correlation coefficient. The slope estimate is -30 point something, right? Then why can we use p-value of the slope to test whether the correlation coefficient is different from 0? Yeah. Sorry. So from the chapter, it's from chapter 10. What was the formula for the t-test that we used to test the correlation different from zero? What was the t-test, the formula? Minus 0 divided by? No. What's the denominator? Go back to the lecture. Square root of yeah, it's a division. No. Yeah, that is true, but we have a specific formula for this. Or Google it. That's right. No problem. Have a nice week. This is a t-statistic for testing the correlation coefficient different from zero. If you want to test whether the slope estimate is different from zero, what would be t-test? Let's call it the slope is beta 1 hat. This is beta 1 hat minus 0 divided by the standard error beta 1 hat. Make sense? We good? These two are the same. Beta 1 hat is equal to correlation coefficient times what? Okay. No, this is equal to. The answer is that if you construct the test for correlation coefficient and you construct the same t-test for the slope, okay, then these two are the same. That's why you can use the p-value or the t-statistic of slope to test whether this is the correlation coefficient is equal to 0. I mentioned this at one point in the last one of the last two classes, but no one probably picked up. Anyway, that's it. Thank you and good luck. So remember, the exam will be on Monday next week at night. Yes.
Have a good weekend.
Thank you. You too.